Okay, so we're talking about properties of exponents, and honestly, this is one of those things that I can teach you in a couple minutes that is hugely important for the ACTs and for, well, for today's lesson and therefore the next test we have. But it's hugely important in math. In fact, it's on my top 20. You know that my top 20 is one of those sets of problems that I think is really important. This is one of them. So product of like bases, that's where like you have the same number for the base here and here, and the exponents are different, and it's being multiplied. That's what product means. So here is an example problem. Would you please see if you know how to do this? A to the 9th times a to the 2nd. Well, it's obviously either a to the 18, a to the 7, a to the 9 over 2, or a to the, let's see, what's the last option? You'd either add them, subtract them, multiply them, or divide them. So adding them would be a to the 11th, subtracting would be a to the 7th, multiplying would be a to the 18th, or dividing them a to the 9 halves, or a to the 4.5. Well, it's one of those. Would you check with the kid next to you and see if you think it's the same thing as they think it is? All right, this is the kind where you add them. Now, I don't want you to just try to memorize that, though. You know what's really, really important is that you understand why. So let's get why. A to the 9th really means a whole bunch of a's all being multiplied, right? So you don't have to write this because it's kind of a pain, but 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a to the 9th. Times a to the 2nd really means that. Do you get why it should be a to the 11th? It makes sense if you think about it. All right, this isn't just like, oh, I should, let me think, should I multiply them or add them? Or you can actually expand them out and know for sure what to put. All right, so if we do the same thing for the next kind, which is quotient of like bases, it's like this, a to the 3rd over a to the 2nd. What does it really mean? It means AAA over AA. Do you get what I just did there? Expanded them out. So now I can actually do some canceling. Once I cancel stuff off, doink, 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 I just have an a left. So it's a to the what? A to the 1st, and therefore do you get we really subtract on this kind? You see how you can, instead of having to like think it through as, gee, should I add, subtract, multiply, and divide? I'll guess one. You can actually expand it out and know for sure that, oh, I guess you subtract these two. What if you go the other way and you have only 2 a's on top, so that'd be like a squared, over, let's say, 4 a's on the bottom? Can I just cancel them all? No. Every one can cancel one, so I can cancel this one and this one, that one and that one, and that leaves what? 0 over AA, 1 over AA, 1 over a squared. Now let's think about that for a second. That is the right answer, but the original problem would have been a squared over a to the 4th. What just happened there? Do you get how it's not quite as simple as just 2 minus 4? Okay. But it is a to the 2 minus 4, which is a to the negative 2. Because I don't know if you know this, but a to the negative 2 is 1 over a squared. They're the same thing. So negative exponents are the first thing we got to talk about that you may have never seen before. How many of you think you may not have ever done negative exponents before? All right, maybe a couple of you. All right, so maybe you think you know them. Let's see how well you really know them. A to the negative 5th, what's it equal to? Because you can't leave negative exponents in your answer. I give you the simplest of all exponent problems. No, it's a good guess, but no. This is a to the negative 5th. That's it. Or is that? Except I think you got the number wrong. I'm not sure exactly if you tried to do that or if, because I expected you'd know it was 1 over. That's right. 1 over a to the 5th is right. Good. I thought that was a 6. I couldn't tell if it was just bad writing or if you really thought it was a 6. All right. So a negative exponent, all it does is takes the original and flips it upside down, 1 over that. So let's say I had 7 to the negative 2nd. Remember, all it does is flip it over, so it's 1 over 7 to the 2nd. Do you get why the answer is 1/49th then? All right, let's try this one. What's 9 to the negative second? 1 over 81. So here's a way to do it. Separate problems into two parts. 9 to the negative second is like 9 to the negative 1, but squared. Do you get how that breaks the negative 2 into negative 1 times 2? And that's 9 to the negative 1, which is 1 over 9, and then squared, and that's 1 over 81. There's a lot of ways to think about it, a lot of ways to do it, but I hope you're getting that these negatives have to do with making the thing into a fraction, and it goes to the opposite side of the fraction. Because where we're going with this is you're going to have problems like this. 3x to the negative third over x to the negative fifth. And you got to figure out where should they go and what should I do with them. And yes, sir. Good question. Is this a better answer or is this a better answer? And I would say leaving me, even though 9 squared is kind of nice and tight and clean, 1 over 81 doesn't have any math problem built into it. So I would say this one wins for being better. One thing I can, obviously they're the same thing, but this one is more simplified, and that's what you're always going for in math. How about this? Can I leave it, my answer as 2? You get done with this big long problem, and you get simplified down correctly to 2a to the negative third b. Do you get you're not supposed to leave negative exponents in your answer? And therefore, the way you should think about this is that just this piece alone is really 1 over a to the third, right? So I got a fun way to just think of this. This becomes 2 times 1 over a to the third times b, and you can do the math on this and put this over 1, put this over 1, and make it into 2b over a to the third. But you can get right away from the right to the right answer if you just think of it this way. Everything is a fraction. Like 8, it's a fraction. It's really 8 over 1. You know what I mean? 2/3 is a fraction, pretty obvious. It's got a 2 over 3, but things that are even whole numbers are fractions. They're just over 1. And so if everything's a fraction, this right here is a fraction with a 1 on the bottom of it, and that a isn't happy where it is. Things that are negative aren't happy, right? So if you're negative about, like Minnesota, because it's so cold outside or whatever, it's finally warming up here, you might be not happy where you are and you should go someplace else. This thing needs to go to the bottom and become positive, and it would look like that. Let me see if you caught on to that. Let's say here's a problem. 2, a to the 0, b to the negative third over b to the fifth. There's a lot of little things to do in here. Just do one thing at a time to make it simpler and simpler, and then give me a final answer. And then turn it my way, and I'll tell you if you're doing it right. Keep it covered up, but yes. Close. The b to the 0 is something. You can simplify that. Yes. Yes. Your b's just disappeared. They were unhappy, so they don't just disappear when they're unhappy. They go somewhere. Yes. 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 You're perfect except a to the 0 is equal to something. I think a lot of people have forgotten what a to the 0 is. Kind of, except your a to the 0 isn't a. Yes, that's right, Noah. And yes. And yes. And yes. Okay, good. What is a to the 0? It's 1. It's 1. If it was 0, it would make the whole top be 0. Do you get that? Think about that. If it was 0, the whole top would become a 0, and then the whole answer is 0. But it's 1. And the reason it's equal to a to the 0 is equal to 1 is actually a pattern. It goes like this. What's 2 to the second? 4. What's 2 to the first? 2. What's 2 to the 0? And think about it. Look at the pattern. Half of this, half of that. See what I'm doing here? And then let's go even further. What's 2 to the negative 1? 1 over 2. because this negative makes it 1 over, right? And look at our pattern. It goes from 1 to 1/2, which is half as big. Does that make sense? Let's try that with 4s. 4 to the second is what? 16. 4 to the first is 4, and you get how it went down by 1/4 as big. So then what's 4 to the 0? 1/4 as big, not half as big, 1/4 as big would be 1. And then 4 to the -1, it's 1/4 as big, and so it would be 1/4. And another way to think of that is the negative just makes it flip, and the 4 wasn't happy on top. It wants to go to the bottom. All right, good. Covered a lot of stuff there. Now, there's a couple others we haven't done. 1/5 squared. Do you get that just both parts need to get squared? That's all there is to it. What's 1 squared? What's 5 squared? So it's 1 over 25. That's all there is to that. Nothing complicated there. But what if it was a squared over a, no, let's make it b. B to the 5th, all of it to the 3rd. Well, then everything has to get put to the 3rd. Just like before, everything got squared. Here, a to the 2nd has to be put to the 3rd, and b to the 5th has to get put to the 3rd. But we didn't talk about that kind yet. What is a squared to the 3rd? What does it really mean? Remember how I said expand it out? What is a squared like? A times a. So this is really a times a to the 3rd. You see what I'm doing here? I'm just making a squared into a times a. And now a times a to the 3rd means you do it times itself how many times? 3 times. So a times a and another a times a and another a times a. And what these really mean is times in between, right? So it's a whole one long big string of a's being multiplied. So that must be a to the 6th. Do you get why I don't add those? Do you get why I multiply those? All right. So what if I had 9 to the 3rd to the -1/3? Whoa. Well, what do you got to do with the powers? Add them. Did we just figure out we added the powers? No, we figured out we multiplied the powers. So we multiply the powers. So if you're ever stuck on one and you're like, oh, geez, this one's really complicated, break it down into little parts. When it's a power to a power, that means you multiply those two things. Okay, so just do that. What is 3 times -1/3? It's kind of 3 over 3 except with a negative. -3 over 3, which is what? -1. So it's really 9 to the -1. Why can't I leave that answer?
1 over 9.
Because you have a negative in the exponent, and you're not allowed to do that. So what's the final answer? 1 over 9. All right, good. Okay, these are rules of exponents, and you've been conquering them pretty well. So here's a little summary quiz. It's not going to count in the grade book, but I want to know how many people can get 4 out of 4 on this. A to the 3rd times a to the 5th. B is a to the 3rd over a to the 5th. C is a over 3 quantity squared. And the last one is 2a squared to the power of 3 all over b to the -2nd. That's the stretcher problem. The first 3 should be easy. The last one might be a good challenge for you. I'll pause for a second while I give this a try. Don't expect everybody here to. I'm hoping for a lot of 3 out of 4s. See if you can be that 4. And we're back. A turned out to be a to the 15th. True or false?
False.
False. That's the most common mistake answer. What is it? A to the 8th. All right, good. The next one, we subtract them. So it's a to the -2nd. That's kind of true, but you can't leave it that way. Did you know that you can't leave it as a to the 3 minus 5 is a to the -2? You can't have a negative in your answer, and power, I should say, and it's 1 over a squared. Raise your hand if you got it all the way to the right thing. Okay, good. And the next part is a squared over 9, because both parts got to get squared. Raise your hand if you had that part right. Good. Now for the moment of truth. Who had this one the same as their partner? I want to ask that. Okay. And that doesn't mean necessarily that you're right, just because you're the same as them. Let's see if you're right. The 2, does it get cubed or not? Yes, it does. That's one of the biggest mistakes. 2 to the third is 8. And then a squared gets cubed and becomes a to the 6th. True or false? True. And on the bottom, I have a b to the negative 2, and there's my answer. True or false? False. Can't have that negative power there. It's not happy there. Move it to the top where it'll be happy. So it's 8, a to the 6th, b to the 2nd. That's my final answer, and it's right. Any questions? I don't expect everybody to have that last one right. There's a lot of little twists in that. All right. What if I had put the whole thing to the 0 power? Is it equal to 0 then? It's equal to 1 then. Yep. All right. This is important. People think that that's equal to 1, and they're wrong. Do you know what they're thinking? They're thinking everything's to the 0, so it's equal to 1. What's actually to the 0? Just the a, and therefore just the a to the 0 turns into a 1, and therefore the answer is what? 2. Okay, now what's the answer? Now it's 1. Why did it change? Because now the 2 has to also be put to the 0. Okay, good. All right, we've covered a lot of the stuff that you need to know. So now let's jump into a tougher one. Let's try that one. Now, the order of operations is a thing. You've heard of it, right? Please excuse my dear Aunt Sally. What is supposed to be first? Please. What does P stand for? Parentheses. So therefore, should I even look at this to the 5th power yet? No, I should be inside my parentheses. Once I'm in the parentheses, what should be first? The multiply or the divide? False. Dun, dun, dun. A lot of people say multiply because, and I'm just going to ask, is this true or not? Please excuse my dear Aunt Sally. Look at that. Multiplies before divide. True or false? False. Multiply and divide are tied. So how do you decide a tie? You just pick either one of them? No. You have to do the one that's on the left. It's true. This might be a, yes, that's a rule. It's a real math thing. If it's there's a tie, you don't just do them. Now, I know what you're thinking. You're thinking something like 2 times 3 times 7. It doesn't matter what order that's true. That's different. If they are different signs, like divide here and multiply there, you have to do them in order from left to right. If you do them backwards, you get a different answer, and it's wrong. Okay, so you got to know that order of operations. So once I'm inside this parentheses, what comes next? The divide or the multiply. You're saying, wait a minute, there's no divide. That's a fraction, so that's a divide. So yeah, that has to be first. So let's do that part of the inside first, and then that becomes n to the what? N to the 9th. Good, because that n to the negative 7 wasn't happy. Move them up here. They join together. Now you get n to the 9th. N to the 9th times n to the negative 9th, all to the 5th. And again, I have simplified one thing and I rewrite the problem. I strongly recommend not trying to do like 5 steps at once, or you will make mistakes. I do, and I'm a math teacher. If I make one thing at a time, I'm almost always right. I try to do 2 or 3 or 4 things at a time, I make too many mistakes. So now what's next? These are getting multiplied. So do I add these or do I multiply them? Add them. What's 9 and negative 9 make? N to the 0. What's n to the 0? What's 1 to the 5th then? It's 1. All right. Let's try another one like that. This one. A lot going on there. What's the order of operations? I got to do parentheses first. So I'm zeroing in on this part. But wait a minute. There's nothing I can do right there. That's true. So then can I just do anything now? No. Next thing after parentheses is what? Exponents. Do you see an exponent in your problem? Actually, I see lots of them. But can I do this exponent right there? No. So the next thing I got to do then is this. Everybody do that to the 3rd. That's got to be next. The order of operations is super important. You can't just jump around and do like little parts of the problem. It has to do the right order. Don't do the right order, won't get the right answer. Once you got that, simplify it out, and let's see if you get the same answer as the person sitting next to you. I'll pause while you give this a shot. All right, so let's see what you were thinking. I hope you got this to be 8m to the negative 12. Do you agree so far? Okay, So then this is 2m to the negative 4th and 8m to the negative 12th. And now now you get two ways to do this. Do you get these guys aren't happy and therefore I should move them? And these guys aren't happy and therefore I should move them. And I can just swap places. But there's a smarter way. Do you get I could really take this negative 4 and this negative 12 and go negative 4 minus negative 12, which means the power is really now m to the, what is negative 4 minus negative 12? That's really positive 8. And that means there's m to the 8 left on top. Now, if you did that simpler by just saying, well, I just move these up and I move those down. Good, but you'll still get m to the 8th on top when you're all done. All right, so that's really 2. And again, if I'm going to do this, move it to the top thing, it'd be like this. And then once you simplify this down, you'll have m to the 8th, and you'll see what I meant. Either way works, it's just one takes more steps. Now, I'm not done yet. I'm not done yet. I'm just saying this is where I'm at so far. Now it's going to be 2m to the 8th over 8. Can I simplify it further? Yes. You remember how if I say if you can factor it, you should? You can factor the 8 to 2 times 4. Why was that smart? Because now you can see what's got to cancel. See what I mean? 8 factors into 2 times 4. Now those are gone, and there's your final answer, m to the 8th over 4. What if a kid said, but I wanted to say 1/4 m to the 8th? They're the same thing. M to the 8 over 4 is the same as 1/4 m to the 8th. Okay, good. Feel like you're understanding it. Sometimes the only way to know for sure is to give you a hard problem and see how many people get right. Try this one, please. I'm going to pause for a second while you finish this. All right, here's what you should have been thinking. I'm going to start on the inside because it's a parentheses. So I'm not going to do anything with that negative 2 until later. Now, within this, you might think there's no other parentheses, but you'd be wrong. There are parentheses, imaginary parentheses that are real, but yet you can't see them. Right here and right here. Did you know that? You might be thinking, well, so everything's in a parentheses. So then what? Well, then you have to pick, and which one comes first? If they're tied, the winner goes to the one that's on the left. And what if I wrote this all the way out? The one that would be on the left is that. Now I got to ask myself, is there anything in there that I should fix? Yeah. The negative a to the negative 3rd is not very happy where it is, right? So let's move him and make him happy and put him down here. And meanwhile, these a's aren't very happy where they are, so they're going to go up to the top. I'm just going to make that one change. Now it's 4. A to the 4th is on top. It used to be on the bottom and unhappy. B to the 5th was fine where it was. It was positive. This is 5, and now it used to be an A to the 4th, but it went up to the top. And now it's A to the 3rd. Has moved down to the bottom, and it's happy. And I still got a B to the negative 2nd. Have I finished fixing the inside yet? Now there's one more thing. These guys aren't happy. Let's just move them up and say this is B to the 7th now. Okay. You with me so far? Now, if I had a choice of doing the negative or doing the 2, some kids are going to square it first, and other kids are going to flip the whole thing over first. Either way works. But do you get at some point everything has to get squared? Because that's what that thing means. That means squared. And then at some point, that negative has to happen, which means it flips. How does a fraction flip? The bottom goes to the top, and the top goes to the bottom. So now, I'm going to pick to square everything first, because that's the easier thing. So I'm going to do it's 4 squared is 16. A to the 4th squared is A to the 8th. B to the 7th. Oh, wait a minute. I should have simplified more. What else can I simplify? Thank you. That's going to make my life a lot simpler. A to the 4th over A to the 3rd means A to the 1 on top. Good question. A to the 4, A to the 3. It's 4 minus 3 makes positive 1. And if it comes out a positive number like that, it goes on the top because that's things that are positive are happy. And all right. If you think of it this way, if it was A to the 3 over A to the 4, then that would have been an A to the negative 1, which would mean the A that's on the bottom. All right. Either way, another way you could think of it, a to the, what was it be now actually for real? Is a to the fourth on top? Okay. Another way to think of it is this. That's a. This is a. And you can go cancel, 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 cancel. I guess there's only one a and it's on the top. All right, so now I'm ready to square everything and then flip everything. Square everything first. 16a squared b to the 14 all over 5 squared is 25. And if I left it that way, it's so close, but I'd have to mark it wrong because you haven't flipped it yet. The negative makes it flip. Final answer, 25 over 16a squared b to the 14. Did anybody have it all perfectly right? 2 people? All right. Yes? If you got the right answer, there's lots of ways to do it. So, all right, 3 people. Good. So, last thought. Your homework for tonight is one big worksheet that is a little bit lengthy. I think I can cut it down in size for you a little bit. I'm going to pause for a second while I find. Okay, so here it is. And I'd say we don't need quite this much practice, so I'm going to let you skip 6 and 8 and 10 and 12. 6, 8, 10, and 12, but I want you to do the rest of them. Okay, so this part right there, you can skip, do the rest. Gotta admit, these aren't super complicated, just moving things around. All right, that's your homework for tonight. Make sure it's ready, because I want to grade tomorrow in class. Get those scores from you, except for you. And that's all I got for you for today's recording.